So of course, after calibrating a scanner, you want to scan. It's not like doing this just for fun. Actually, calibrating is normally the thing that is bothering the people more than scanning. So I was just thinking what to scan, and I looked around on my table and I found an Arctic Spider standing here. So let's scan a scanner. I'm going to scan the Arctic Spider right now. So I'm just going to put it on the turntable. I want to do a turntable project because I'm a lazy person and turntables are really cool. I just don't have to do so much. And we are going to give the project a name. Let's say Arctic Spider handle, whatever. We are going to do a different folder. Arctic Spider. Okay. And remember this location. I just don't want to select every time again the area or the folder where I want to save the things. So that's absolutely fine. So simplification level means that the scan will be simplified automatically. What I don't want in this case, I want to use maximum resolution, because as well the Neo is not a high resolution scanner, so I don't have to care too much about numerous amount of data that he's creating. That's absolutely fine. A low camera resolution as well, no texture. In this case I don't need the colors of the spider outside, because actually I'm not going to use it for any kind of the renderings or so. Project with markers could be, but it's not necessarily needed. When do I need project with markers? So if you will open up the Neo package, there is a bunch of markers to stick on the object, or you can stick them on the turntable as well. Many times it helps, and it does not need it to stick it on the object and remove them. If you have objects that have a very, let's say, homogeneous curvature on the surface, like a ball for example, or some sphere that is cylindrical, or a cylinder, whatever, everything that have no curvature changes, where two scan pictures cannot be aligned very easy for the scanner because both of them look similar to each other, they will need it. So in this case the Arctic Spider is not too complicated, but as well it's not too homogeneous in its surface. So if you imagine in that field of view of the scan, you will have the pictures, they will be easy to be found to each other, but they are not looking very similar, so you don't need markers for that, in my opinion. Okay, so axis evaluation of the table. I see in my test so far that this brings you benefit in the alignment time. That means you will have the scans aligned to each other faster. So I will do it. I can do it over the plate. That means again, maybe this is more needed for objects that have not so much curvature information. I was absolutely fine in objects like this that don't need markers to evaluate it by the axis by an object. That means there will be done some scans of the object and they will be compared, and the software is calculating automatically where is the turning axis, and the further scans that you will do later on, they will refer on that axis and will find very fast its position to each other. You will see that later on when the software is processing the data. So I will do it. I think it's good, so I will say continue. Okay, we come to the scan menu. In this case I will check first the rotary table increments, or maybe even first it is better to think about the distance of this scanner, in this case to the scanner itself, no, actually to the object, to the scanner. That means the spider to the Neo. I just don't want to scan so many rounds, so I'm going to go a bit further. I have no flexible scanning field in the Neo, so I'm just able to change the distance of the object. So in this case I'm going here a bit further back on the table. I think maybe like this. If you are going too far away, you might enter into problems with capturing, because you are out of the field of view, you will get not so nice precise surfaces in this case, but as well it is a problem that the object itself will go out of the scan areas from the cameras. It means if you are going to go very far away or so, the objects will actually drift to the borders or the corners of the scan field, what means they will not be captured anymore. So you have a limited scan field anyway, even if you go further away. You are right now reducing a little bit surface resolution because you are not fully using the scan area for the object. There is a lot of environment that have no information that I need that will be captured as well, and let's say the pixel per inch, if you want to speak in the photography language, on the object will go lower. That's a topic, but not actually for this scan. This is let's say some freeform surfaces. I just want to get the shape, and the neo let's say resolution will be more than enough, no problem in this. I just want not to spend too much time on scanning and scanning again, so I just want to capture as much as possible in that scan area, and that's why I'm moving backwards. For me, resolution, that means small details in this case are not mattering at all. So I'm going to go back and turntable. Okay, we are going to perform a background scan. What is it good for actually? In many scanners you scan something and you are scanning a lot of things that you don't want actually. Your table, your pens, whatever is on your desk or in your environment. In this case, I think this is one of the cool features that Range Vision software is offering. You can scan the background. That means you are scanning what you don't want to appear in your scan, and it will be like a mathematically subtraction. These things that will be scanned right now are not going to be on your scan. Okay, but I see that picture is really dark, and as well, if I put back the scanner, I see the scanner is really dark, and there is some gray areas. I will have to brighten up the scanner. Why is it important? The cameras work with light, and the capturing is working with light. It means if you are going dark, capturing starts to get more complicated or impossible. So I'm just some person who's defending to scan on the brighter edge of what is possible, because you are lighting up all the details. They will be more visible. Where there is light, there will be capturing. And on the other hand, if I over brighten, that is marked by the red areas, the information is not usable. There is no, let's say, surface information anymore captured, because everything will be white for the algorithm, and that's why it's not going to capture in this case as well. So too dark is not good, too bright is not good. I have another problem here in the spider. I have some area that is darker, that is gray, and I have some area that is white. So for the gray area, this would be fine still. I can go much brighter. Still I will have problems in that area. Right now you see you're absolutely overexposed. That would be nonsense. So we are going down. Okay, so for me that gray area looks right now reasonably regarding light, but the white area is actually over brightened. I can try to find a compromise, do it with one exposure, but I don't have to actually. Even with the Neo, the Range Vision software is offering you a cool feature, that's second exposure. What does it mean? If you go here, okay, everything is like very dark. I can go up and I see I have the same parameter to play with. And what does it mean? I have going up here, I can see my first exposure. Going down here, I can see my second exposure. I have two settings. The scanner will do in one scan, first exposure scan, don't move the object, to second exposure scan, that will capture the areas that are, for example in this case, are brighter. The white areas will be better captured, and will merge them together before he turns, and you will capture a very wide range of surfaces that actually will help you very much. And that's really cool, I guess. Even for a Neo, that's a really good feature. Okay, so I think the white areas are fine with this exposure. I can brighten up a little bit if I want to. Okay, it's fine. Don't get confused by the fact that he's going back in the preview to the first exposure. You can do it the opposite, so you will not see so much red if it is, let's say, confusing you. And you are fine, I guess. So axis evaluation, we stopped here. He will do right now that what I explained before. He will do 2 scans and will compare their position to each other and will calculate a rotary axis. So nothing more happening than a scan. These scans are not going to appear in your model tree later on. They are not part of your project, so don't care or bother too much about the result or whatever. It is just about positioning the object in the world coordinate system. That means in that numerical room. Actually, the scanner is creating a room where there is nothing in the beginning, and right now you start to put things inside that room. And you right now giving the position of the area of interest for what you want to scan later on. Okay, nothing really special, you just have to wait. And I start scanning. And this is the really good thing about automatic turntable based scanning. You are just clicking the button and let the machine do your job actually. So the next view will be the side view. I will capture it and just turning the device and start again. So it's done, and you can see that the automatic registration is really working very good. So there is nearly everything done. So I can see that I just have a problem in the lower areas of the flange, and I'm going to scan just a few of them. That means I'm going to position that around, and I'm going to define some angles. That means I just want to scan that area below with a few more angles. So let's say 0, I'm not sure, 20, 30. I just want maybe some more around the edges. 35, 45 maybe just already. That will be perpendicular, that should be fine. And on the opposite side then it will be 300 305, 330 and 340. So let's see what will happen. And start scanning. So right now you can see I didn't even have to touch the scans and make some kind of manual alignment, and it filled up the areas that wasn't perfect with some really dedicated scans for that area, what I think is really useful and that is really amazing and time saving. So I'm going to finish scanning. Of course I could try to get all the small edges and areas that I didn't perfectly scan, but for the demonstration I don't need it, and it's let's say something I'm not going to use for processing later on, so I think it's fine in this point, and we are going to continue to processing. So in processing I'm able with the normal tools to mark some areas with control and points, and I can do some operations on them. I can delete them, whatever. It's quite the same, just play around with it. There is the lasso that you might know from other sketching tools, so you can sketch on the mesh. It's just pushing control. There is a right angle that you can open up, and whatever. It's for cleaning and post-processing, the things that you should know are actually, but I don't need it. The cool thing is I'm finished actually. I'm just going to post-process right now the result, and registration will be the next. That means all the scans in this moment are put together in some let's say way that is not finally because of the processing speed and so on. I'm just going to start let's say global registration. That means I'm just going to do this alignment to each other. Register is here in this case a redefinition of the position. So right now all the scans are positioned to each other, and there's, let's say, a deviation of 61 microns, what is actually quite fine compared to the class that the scanner is working in. And right now I'm able to create a watertight model. There is several options, but on the Neo it makes no sense to speak about metrology. This is in this case a classic model that I will generate. The level of model resolution I will keep it in the standard, because as I don't have very special needs, I'm just going to apply the resolution that's absolutely fine in the presetting. I'm not going to remove small components in the first step, just to see how it will look like. Unload scans for memory will help you to process the data faster. It means the scans are taken out of the RAM, and if you have a not so strong machine, it's really useful. You will have to, or the program will reload them. It will take some time afterwards if you need it. But as I'm running on some good notebook, I'm just not need to do it. So I can really go just using the standard settings, don't change anything, and create a model. And we are finished. The merge is done, and not sure what you think, but for a scanner that's just a little above the 1000 euros with an automatic turntable, the result really looks amazing. I have here not enough information. I should have made an additional scan of this area and the upper area, I got to admit, because it's not captured very well, or not perfectly captured, but for making at least some print for 3D printed, or make a 3D printed holder for it that you want to use to put it into your toolbox or wherever, it's absolutely fine. So even if I take a look in the writings, it's readable. They are not too sharp in the original device anyway. Of course, I can go right now and export it. Processing, I think I can simplify. That means I can make that mesh at least less heavy. That will take out a lot of triangles. I can do smoothing, but for smoothing I have to mark some areas, or it's recommendable. It means if I have some strange edges or so, I can smoothen it. That will be a rather radical change that I will cause right now, but anyway, it's just for showing you what is possible. If you mark some area with the marking tools, that like with the lasso or the triangles and so on, you are just going to apply that algorithm on that area, what is right now applied. And that means, for example, I can go here and use some area, pushing control, marking it, and say, oh, I'm going to smooth that area especially out. I can do that like this, and you see this is just applied in this area. In this case, mesh simplification, everything's fine. It's quite common in all the software. It makes it model smaller. I'm going to apply it. You will say that this model will not suffer too much. Quality of the scan is good enough that you can reduce it to half the size without any really big problems regarding the quality. If I want to export it, I can go and say, okay, I'm going to export it. Let's say I make some export folder, and I'm going to export it as an STL. Oh, sorry, I cannot export all the mesh, or at least all the scans. I just have to select the mesh. So where is it? Model, sorry, model and export. And I have it right now. I can go to my folder. Feedback is not what I was looking for. I can say okay. Spider handle export, and I have right now a file of 90 megabyte, and yes, I could reduce it much more. So just for giving you an idea what you are able to do with an Arttec Neo, it's actually a tool that's absolutely perfect for beginners, but I don't recommend it for children, let's say necessarily below 12 years. I think for 16-18-year-old that are a bit forward and that are skilled, they will be able to work for it. It's perfectly doing well with students and academy grades. And what is really cool, I will make a video about it as well, what you have as additional possibilities that you can do with this platform. But that's for today. I think you are able right now to scan with the Neo, and if you have any further questions, write them down low in the comments. Thank you.